see, baseball players, they all look like the same. They always wear that weird suit and then. Okay. All right. Anybody here is a baseball player? No. Okay, good. Your class consists of 11 men and 8 women. Your class consists of 11 men and 8 women. I don't actually know exactly how many we have. 1, 2, 3, 4, 5. 5 women, in fact. Let's change them. Let's say we have 5 women and how many men? 4, 6, 7, 10, 13, 21, I think. Okay, so after the final exam, the students are ranked according to their performance. Okay? So after the final exam, all of you will be in the class, and I'll rank you guys, and then I'm gonna tell everybody what their ranks are, right? In front of everybody. That's a joke. Well, that used to happen to me when I was a kid, but. So after the final exam, the students are ranked according to their performance, and assuming that each student has a distinct ranking, how many different rankings are possible? Is the question clear to you guys? How many different rankings are possible? So you have 21 students who are 21 male students and 5 female students, and you are ranking them. All of them will have distinct ranks. So how many rankings are possible? Anybody? I'm sorry? Somebody said 26 factorial. Do you guys agree with that? Yeah, so basically we are trying to find an ordered arrangement of the 26 students, right? We'll be arranging the students in order of their rankings, right? So the answer is the same as number of ordered arrangements of the students, right? Which is the same as the number of permutations of the students. And so the answer is the number of permutations of 26 students, which is 26 factorial. Now change the question a little bit. So refer to the previous example, and now we are going to say if men are ranked among just themselves and women are among just themselves, then how many different rankings are possible? So now I'm saying that I'll be ranking the female students separately and the male students separately. Okay. So I have 5 female students in the class, right? So that means I'll be ranking them 1 up to 5, and then the male students will be ranked from 1 up to 21. Okay. So what would be the answer in this case? (21 factorial plus 5 factorial. Does everybody agree with that? Somebody said no. Why? Times 5 factorial? Okay, why? Very good. So for every arrangement of the for every ranking of the female students, there are 21 factorial rankings available for the male students, right? So another way of thinking about it is that experiment 1 is pick a ranking of male students, and then experiment 2 would be pick a ranking of female students. Now, experiment 1 can be done in 21 factorial ways, right? And then number of permutations of the female students would be 5 factorial. So experiment 1 has 21 factorial outcomes. Experiment 2 has 5 factorial outcomes. So by the multiplication rule, right, the number of possible rankings of all the students would be 21 factorial. Oops, 21. Let me erase that for a second. 21 factorial times 5 factorial. Does everybody agree with that? Because for each possible ranking of the female students, I have 21 factorial rankings of the male students, right? Does that make sense? Here's another question. Suppose Mrs. Roberts has 10 books that she is going to put on her bookshelf. Is it discrimination to say Mrs. Roberts nowadays? No? Is it still a custom? What is that? Yeah, I mean, do you have to take on the last name of your spouse? But people can prefer to take it? Okay. I'm just checking. So suppose by the way, my wife doesn't take my last name, so suppose Mrs. Roberts has 10 books that she is going to put on her bookshelf. Of these books, 4 are mathematics books, 3 are chemistry books, 2 are history books, and 1 is a language book. I have a typo here. G is missing, right? Yeah, typo here. Okay, so Mrs. Roberts wants to arrange her books so that all the books dealing with the same subjects are together on the shelf. How many different arrangements are possible? Is everybody clear on the question? So she has 10 books. 4 are mathematics books, 3 are chemistry books, 2 are history books, and 1 is a language book. If this bookshelf belonged to me, I wouldn't have any chemistry books in it. The other ones are okay. History and language is okay, but chemistry, no. Okay, everybody gets the question? Okay, what's the answer? So remember, you want the mathematics books together, you want the chemistry books together, you want the history books together, right? And the language books together. Just 4 factorial? Anybody else? So why are you saying 4 factorials? So you are just arranging the 4 subjects? Am I correct?
Yeah.
So your 4 factorial means arranging the subjects. So think about a shelf, like just one shelf row, and then you're arranging the subjects, right? So 4 factorial is the number of ways to arrange the subjects. Anybody else?
Is it 4 factorial times 3 factorial times 2 factorial times 1 factorial?
Okay. Now, anybody else? Pretty close.
4 factorial again?
Yeah, you have to combine both of yours, right? First of all, you are arranging the subjects. So how many ways you can arrange the subjects? And then once you have done that, you can arrange the mathematics books among themselves 4 factorial ways. You can arrange the chemistry books among themselves 3 factorial ways. The history books 2 factorial ways, right? Am I making sense? So first of all, you have to pick an arrangement of the subjects, and then you pick an arrangement of the books in each subject. So first of all, you pick a arrangement of the subjects. One possible arrangement is that you're going to have the chemistry first, then the history, then the mathematics books, and then the language book, right? So first of all, first thing you need to do is pick a subject, right? Pick an arrangement of the subject. So pick a permutation of subjects. And that can be done in 4 factorial ways. And then you can pick a permutation of the math books. That can be done in 4 factorial ways. Pick a permutation of your chem books. That's what you say, right? Chem? No? All right. 3 factorial ways, right? And pick a permutation of history. I never heard anybody saying hist for history. I heard math for mathematics, chem for chemistry. For physics, is there something? Probably not. This would be 2 factorial. And pick a permutation of the language. That's going to be 1 factorial. So the answer is 4 factorial times 4 factorial, 3 factorial, 2 factorial, 1 factorial. Whatever the number is. Is everybody clear on this counting problem? Any questions on that?